class, for the rest of the term, we're going to be learning about hypothesis testing. The first step in a hypothesis test is to state the question of interest. Now, this is really practical in the real world sense. In academia, we'll simply just restate what the question is asking us. The second thing is to plan. So we should state the parameter of interest. Typically, this will be mu in this particular class because we're talking about population mean. Then we should always state the null and alternative hypotheses that reflect our question of interest. After we do that, then we can start checking the conditions for our test. So whether or not the conditions have been met for us to do the procedure that we're interested in doing. After we do that, then we can do the math part, which is to calculate test statistics and find p-values, and then also to calculate confidence intervals if we want to do a comprehensive 4-step conclusion. The last part is then to make a conclusion. So we want to make a meaningful conclusion based on the context of the problem and using the information from our analysis. So what was our test statistic? What was the p-value? How did it turn out with our question of interest? What would it be if we estimated the parameter? And what is the confidence interval then for that? So typically, a good conclusion has these 4 parts. That is a statement about the strength of evidence for the alternative hypothesis in the context of our problem, and we can use this scale for that. So if we find a p-value of 0.02, then that's going to be moderately suggestive evidence in favor of our alternative. Okay, so one statement like that for our conclusion. Then we should include the estimate and its interpretation. So give the estimate or the sample mean, so the best guess, and interpret that back into the context of our problem. In addition to giving a point estimate, we should always give a confidence interval. And that is, we should give then the 95 or 99 or 90% confidence interval for our parameter estimate. And this will then give an entire comprehensive conclusion based on our question of interest. And lastly, this is then the simplest of the statements, and that is whether or not we're going to reject or fail to reject the null hypothesis with respect to our p-value. So whether or not our p-value is smaller than our significance level, then we're going to reject the null hypothesis. If it's greater than our significance level, then we're going to fail to reject the null hypothesis. So this is then the 4-step write-up in which I'd expect you guys to be able to do for your hypothesis test. In addition to this, if you need a little bit more help in interpreting confidence intervals, I've written up this rubric that you can use. Instead of trying to come up with your own, you can practice with this first. So this would mean the 95 or 99 or whatever level confidence you are choosing % confidence interval for our true population parameter. Then you're going to put in mean or proportion. The context of the problem is on average estimated between your lower bound with units and your upper bound with units. This will really help you push forward into the next section of the course, which is the hypothesis testing and the confidence intervals, if you have this part down.